Hello everyone, this is Daniel Pinheiro from danielpm1982.com and welcome to our first lecture about XML. So, what is XML? The abbreviation XML stands for Extensible Markup Language, which is a little bit similar to HTML, although there are a lot of differences between them. And the purpose of XML, differently from HTML, is to store and transport data over the internet so that different systems, especially heterogeneous systems, can have this data transferred between them in a format that is both human and machine readable. For example, one could have a request for a server A, which runs Java as the backend language, and this server A could have to communicate with one or more other servers, and these other servers could be running .NET or any other backend language, and both server A and server B should have a common language to talk between each other without further overhead in translating from one language to another and from the other to the first one. So the best way so far for transferring data between different servers is by far using XML, or more recently using JSON. So these are the two main formats in which data can be stored and sent over HTTP in order to facilitate the communication and also the understanding of the data, as well as the production of new data with easy conversions between a certain language to XML, then from XML to the other language, and at the return from the other language to XML, and finally from XML to the first language. So most of the effort is done by modern APIs. All backend languages have APIs that deal with XML conversions, and as an example, we could consider the Java to XML marshalling conversions using JAX-B, and also the conversion back from XML to Java or unmarshalling using the same JAX-B Java API. So it's not the programmer who is in charge of making such conversions. Okay, so who maintains it and what are the specs of XML language? The main maintainer of XML language specifications is the World Wide Web Consortium, or W3C, and the implementation of W3C is actually on version 1.0, but in the 5th edition, the implementation and specification can be found at the recommendation, or REC, from November 26, 2008. It's the latest version. And W3C has been responsible for implementing and maintaining these specifications since 1998. And the World Wide Web Consortium is by far the most important partner in respect to the specification and implementation of XML and other related technologies. So the characteristics of XML language are the following. It is based on self-descriptive tags representing only the structure and info of the data, but not anything about its displaying or processing. That's one of the differences between XML and HTML, because in HTML the main purpose is the structuring of the web page and sort of the displaying of that info to the final user alone or in association with CSS. But with XML language, the only purpose is to structure and to store the data so that any system that can understand XML can take that data along with its correct structure. Another important characteristic is that there are no predefined tags, different also from HTML, in which you have a lot of predefined tags. Actually, all tags are predefined in HTML, but with XML, you don't have predefined tags, and you're responsible for creating all tags. And in practice, it is done by importing XSD files, and we'll talk about XSD later. But for now, you should know that you have an XSD scheme file where you specificate or declare all tags for that XSD, and then you import one or more XSD to an XML file, and at that XML file you can use those tags and attributes that were previously defined customly, not as a standard, customly at one or more XSD schemes. So you have one XSD scheme, and for that scheme, which is as analogy like a class for objects, with that scheme, XSD scheme, you can create a lot of XML documents or instances using those tags defined at the XSD, inputting some data, some text data for that previously defined structure. But this predefinition is not done by W3C, for example. It is done by any programmer or by you yourself at the XSD scheme, and then it is used at the XML file where you use the tags and attributes with the data for that instance. For example, if you have an XSD scheme for patient records, you will have one XSD scheme, and for every patient you have, you will use that XSD and the tags and attributes for creating the XML document or instance for each one of the patients. If you have 50 patients, we will create 50 XML manually or automatically, as I've said before, through the APIs, but the XML files are unique for each instance, and they are all based on one or more XSD schemes, where you define the elements that are going to be used by any XML implementation of that XSD scheme. XML technology simplifies data sharing, data transport, platform changes, as well as data availability. XML also stores data in plain text format, a software and hardware independent way of storing, transporting, and sharing data with no data losing or compatibility issues between different or heterogeneous systems, or between a system and a human user. So, XML also facilitates XML-based platforms to change and evolve, as no changes have to be done on the data XML representation. If you have 10 systems synchronized and using the same XML, you can change any of them, and no changes are required for the XML or XSD that are used between them. So, XML can also be read easily by humans by programming APIs as JAX-B in case of Java, by voice, synthesizers, and all sorts of algorithms, both at the front end with JavaScript, for example, as well as at the back-end development layers using Java or .NET or C#, PHP, or any other language, programming language that understands XML format. Some more characteristics here. XML separates data from presentation or from the view. Despite any view or presentation changes, the data is always the same, as well as its representation on the XML file or at the XSD scheme. When the view is necessary, for example, as for final user systems, when an information is to be shown to the final user at an HTML page, for example, XML is generally used along with HTML and CSS. And these are the two who care about which part of data to show and how to organize it along the web page, in which style to use, not the XML. The XML itself only cares about its data and the elements and attributes that structure it. Either at the back end or at the front end, XML can be consumed or produced using any programming language, and the data sent to the view for displaying or for being consumed by another server, for example via SOAP or REST web services. One more characteristic is that XML can be used to represent and transfer any human machine understandable data within any field of human knowledge using many different programming languages, as I said before, most back-end languages as well as some front-end languages. One other important characteristic is regarding the syntax. It has a tree-based structure of elements or tags similar to HTML. So here you have a simple example of an XML file with only element tags, and the structure of the data, the text data stored at this structure or XML file. This text data is structured using the elements or the tags, which can be defined in a certain XSD imported by this XML file. But in this simple example, I just want to show you that the tags are structured into a tree-based structure, which can be represented as here on the right, from the root element, the most outer element, to the inner ones or the leaf elements, and you can have any number of levels or any number of inner elements inside each element. So here in this example, this XML file represents an animal group, and let's suppose there's an XSD that defines each of these tags is an instance of that XSD storing some information about a certain and single animal group, which is the root element, and you can have only one root element. So at most this XML represents one animal group, And for this animal group, you have two other inner elements, a dog and a cat. And for the dog and for the cat, you have some other inner elements that specify the characteristics of that dog and of that cat, as the name, the species, the color, the birth date, and the owner. I just would like to show you how the tree-based structure of any XML file can be represented using a tree structure tag name, as here. You have a root element. Inside that root element, you have other inner elements in any number of levels or with any number of other elements inside. Here is a more realistic XML file. We'll explain everything and every element of it at the end of this class. We first have to talk a little about every one of them, but here I just wanted to show you a more realistic XML file. It's not as simple as this one, but as for now, you can see the root element. You can identify the root element and the inner elements, a dog, a cat, a rabbit. Inside those inner elements, you have other inner elements. So, XML related technologies, most of them are also specified and implemented and maintained by W3C. For further information about any of them, you can access any of these two links. This one, w3schools.com. It has some easy tutorials about each one of these stacks. And this other link or site, w3.org, it contains all recommendations or all documentations in detail about each one of these related XML technologies. So it's up to you to specialize on that if you want. But at these classes, we'll talk a little about XML, about XSD, about WSDL, and we'll show you some real examples, not only static or picture examples, but in the second and third lecture about this topic, we'll also see how to create these files using Eclipse and how to check if the written XML file is well formed as well as valid when confronted to the XSD scheme. So I decided to list all related technologies here. We will not see each one of them, but it's important for you to know what exists, so that if you ever need to specialize or to study any of them, you know where you can find the info necessary for that. So the XML related technologies are XML, of course, the Extensible Markup Language, the XSD, which is the XML scheme for the XML document instances. You have also for web services the Web Service Description Language, which is an XML file, but a more specific one that relates to the web services, either REST or SOAP. And these are the three we're gonna see. In the first 3 lectures you see only about XML. In the other 3 lectures you see a little bit about XSD. And at the other last 3 lectures we'll see some aspects and examples about web services description language files. Other than these 3 technologies and related to XML, you also have the XML DOM, or Document Object Model, which is pretty similar to HTML DOM. And with this XML Document Object Model, you can access and manipulate the elements of a certain XML file, as you also can do with HTML. You'll also have the XML XPath, the XML XSLT, the XML XQuery, the XML XLink, the XML AJAX, the XML DTD, or Document Type Declaration, which is actually an ancient form of representing the scheme for XML files. Nowadays, you only should use XSD. At the second topic about XSD, I'll show you some differences between XSD and DTD so that you can make yourself pretty sure that you never need to use DTD unless you're dealing with legacy systems. You also have the HTML, or Hypertext Markup Language. You also have the CSS, or Cascading Style Sheets, that abstracts the style information about HTML and is used along with it. And you have the programming languages as JavaScript as a front-end language, as well as any other language whose APIs can deal with XML data representations. So regarding the XML general syntax, there must be one and only root element on each XML document or XSD instance, into which other elements may be nested or not. You can have an empty root element, but commonly you have a root element and other inner elements nested inside it. You also have the prologue, which is optional, but always the first on the document. This is the prologue. After the prologue, you have all element tags starting from the root element, and every single tag in a XML file must have a opening as well as closing tag, except the prologue. As you can see here, there is no closing tag because the prologue is actually not part of the document, but any other tag surely is. So you open the tag, you define maybe some attributes inside, then you close it, you put the information, and then you use another tag closing the element scope. You have an opening tag and a closing tag for each element with the information in the middle of both. Another thing is that tags are case sensitive. Also, XML elements must be properly nested. The inner ones must be closed before the outer ones in a correct sequence in order for the file to be well formed. And attributes may be set inside the respective element, actually at the opening tag, and if they are used, the values of the attributes must be quoted. We also have the entity references, which are pretty useful for text characters that would interfere with the syntax, as the less than or more than symbols, or the and symbol, or the apostrophe, and quotes as well. So for these symbols, you have entry references. Here are the 5 of them. And you can use, instead of these characters, the respective entry references, so that the code at the XML won't be broken. For comments, it's similar to HTML. You have the less than and exclamation, hyphen hyphen, and for closing, hyphen hyphen, more than. One important thing here is that the double hyphen cannot be used inside a same comment, or else the codes will be broken. Also, white spaces are not truncated to 1, which is what happens with HTML. Another thing is that a new line is represented as a line field with no carriage return, and XML documents or XSD instances that bind to the syntax rules are said to be well formed, and those that comply to the XSD schemes are called valid. You must have a XML file which is well formed by itself, which complies to the syntax rules above. And you also, if you're using an XSD scheme for validation, you also have to make the XML file valid when compared against the XSD scheme. That way you have a well-formed XML file which is also a valid one compared to a certain XSD custom file. So regarding the XML specific syntax, we start with the XML elements, and XML documents are made pretty much of elements, which are the whole thing between the opening tag and the closing tag, these tags inclusive, which means that an element in XML begins with the opening of the opening tag and ends with the closing of the end tag or the closing tag, and includes everything between. So here we have an example of a client element which starts with its opening tag, which is this part here. And at the opening tag you might have attributes. In this case we have an ID attribute representing some metadata about the client, in this case with a value of 50 between quotes. Then the starting tag or the opening tag is closed, and next we have the text data itself, which is the data we are structuring through these elements we are using. And after the texting data we have the closing tag of the same element. So the element is everything here, and the tags are just what is within the opening and the closing tags, not the data itself. So the data is included inside the element, but between the tags, the opening and the closing tags. Next, an element may contain text, as here, John Smith. attributes, specifically inside the opening tag, as here, id equals 50. Nested elements, which would be placed here between the two tags of the client element, nested inside. And the element also can be empty, with or without attributes. So here is another example for showing how the nesting of inner elements can be done. We have an outer element, client, with its own attribute, which starts here and ends here. These are the two tags of the client element. And within this client element, nested inside it, we have two other elements, element name and element dependent, so that the first element have some data inside between its tags, and the second inner element is an empty element which have the two tags, the opening and the closing tags, but no information or text or any other inner element between its tags. So its dependent here is an empty element, and it can be represented by a opening and closing tag with nothing between them, or by an opening tag with a slash at the end of it, so that you don't have to use another closing tag right next to it. Still regarding XML elements and considering the element naming, element names are case sensitive. They must start with a letter or underscore and not with spaces or numbers, for example. And element names cannot start with the letters X, M, L, or any variation of this sequence of chars. Element names can contain letters, digits, hyphens, underscores, and periods. Element names cannot contain spaces, and any name except XML can be used with no reserved further words. Regarding element naming style, you're free to choose the style to use. You can choose your own style or any of the commonly used styles, which are these 5. We have the lowercase, on which all chars are put as lowercase. We have the uppercase, in which all chars are uppercase. We have the underscore, with all chars in lowercase, but with a underscore between the words represented. We have the Pascal case, which always starts with an uppercase and with another uppercase letter on each new word. And we have the most common style, which programmers are pretty used to, which is the camel case. That is the naming style for variables in most modern programming languages, in which the first letter is always lowercase with an uppercase letter on each new word that is combined with the previous word to form the element name. So, as a best practice also, you should create simple, short, semantic, and auto-descriptive names. Avoid punctuation chars, and also avoid non-English chars, as most of the languages, if not all of them, are written in English, and these languages and their platforms are the ones who are supposed to use your XML represented data, so for not mixing things up and end up with inconsistencies, you should also write your tag names and content in a English form. So another central characteristic here is the element extensibility. For example, if an app uses an XML document to show a message at the view, the XML document can have its elements extended with new elements, and the view still works, eventually updating that new elements or not without crashing. So the XML files with the data representation is pretty flexible and extensible. For example, you might have a root element with 3 inner elements that is used by a system, for example, for showing to the user, the final user, some info. But you can, in any point, extend that XML to add new elements, and it won't crash the displaying of data at the system in which it's been used before. Now, XML attributes, other than elements, the second most important component of XML. Attributes store pieces of information about the element in which they are set or declared or defined, not about other elements. So for each element tag, at the opening tag for that element, you might have some attribute which will carry pieces of information, especially about the structure, not usually the data itself, and that attribute will store that information only about that element in which it is defined. Attributes values must be single or double quoted. You can use either of them. If a attribute value has a quote on the name itself, you can, for example, interchange at the declaration of the value to the other option. For example, if there's a single quote on the attribute value, you can use at the declaration for that value the double quote, and vice versa. Or you also can use entity references, as we've shown before. Just as an example, a move name is the value of the attribute. So, and for move you have the double quote. It is this, everything here is the value of the attribute. So at the declaration of that value, instead of you use double quotes, you just change to single quotes for not breaking the code here and for avoiding creating any inconsistency. But also you could keep using for the declaration of the attribute value the double quotes, and inside the value at the place you would have double quotes, you can use the entity reference for double quotes, which is enamp char plus quote. And this entry reference is later converted to double quotes. And some disadvantages of using attributes inside element tags are that attributes cannot contain multiple values differently from elements. They also cannot contain tree structures, and they also are not easily expandable for future change as elements are. So when to use attributes and when not to use. You should use attributes for metadata only, that is, for info that does not refer to the data semantics or business logic. For example, an ID of a person, but not the data about the person itself. So you can use a person tag or element, and inside that opening tag you can use an ID attribute for person, but you should not use information about the person like name, birthday, nationality as attributes. You should use them as inner elements. So the semantic or business logics should be put inside inner elements. And for attributes, you should reserve only data associated to the metadata of that element. For example, the ID. And you also use attributes when the metadata represented by the ID is a simple value, for example, a text value, and will not need to have any complex structure or multiple values. So even for metadata, if you do need to use any complex structure or multiple values, you should change the design, and instead of using attributes, you should put that metadata inside inner elements. So if the attribute is not to be used for any of the reasons above, you simply add an additional nested element with the data that would be used as the attribute value. So either add an attribute or add an inner element, the data will be easily generated and consumed by the application, and there should be no problem related to the use of that data. And lastly, the final thing at this theory lecture about XML that I like to show you are namespaces. We've seen elements, attributes, the prologue, and now the fourth main component of an XML file are the namespaces. So namespaces are useful to avoid name conflicts of elements when creating valid XML instances from XSD schemes, because you may import one or more schemes with different elements, although with the same names. And it's also useful when different XML instances are going to be used by the application. The elements that are going to be used must be unique. So if you have more than one element with the same name, either at the XSD that you import or at different XML instances or documents, the unique namespace and the unique prefix you define just after the namespace both guarantee that uniqueness. XML namespaces are defined by the attribute XML and S column, the prefix, followed by the URI between double quotes. For example, here, the definition of this namespace, you use the XML namespace attribute column, a prefix. In this case, I've used the prefix Daniel PM 1982, then equals, and between double quotes you use any text name, but generally a URI. It doesn't need to be a valid URL, any name you want, just to differentiate and make those elements that are related to this namespace unique. So if you want to use the elements for a certain namespace, you just precede the elements declaration with the prefix. For example, here I've defined the namespace with the namespace danielpm1982.com/xml, and I've also associated that namespace with this prefix. So when I want to use the namespace, I just have to use the prefix in a column and then the elements that namespace defines. For example, through the importing of a XSD. Another thing, if the attribute XML has no prefix associated to it, then it's considered the default namespace. You can declare any number of namespace you want, but if you don't use a prefix, the namespace will be considered the default for all elements inside that element in which you're defining the namespace. We'll show you how to define where to put this XML namespace attribute in the next slide. But for now, you only should have in mind that if the namespace is considered the default, all elements that are used inside the elements in which it is declared will have access to the elements of that namespace without any prefix requirement. But it is of the best practice to always use prefixes when defining a namespace. So the attribute can be declared and defined at one or more inner elements or at the root element of the XML document for all elements of the XML instance in the case of the root element. So now let's analyze more carefully the second example we've presented before at the start of this lecture, which is the animal group XML with a dog element, a cat element, and a rabbit element inside, in each of these inner elements with some other descriptive elements nested inside them, the name, species, color, birth date, and owner elements. So the general picture you might already have understood, but what I like to show you now, as we've just seen namespaces, is how an XML document instance, which is this whole file, can refer to an XSD document schema in order to use the elements, attributes, and types created at that XSD at the XML document instance, as here we show. First, you have here the prologue, just remembering it. Next, you have a root element, in this case the animal group root element, which starts here and ends at the end of the file right here, with an opening tag for the animal group, which starts here and ends here. This is the content of the opening tag for the animal group root element, and this is the closing tag or end tag for this same animal group element. So another thing is, as we've already mentioned it, at most one root element is permitted at any XML file. So at most we have at each XML file that's gonna make use of this XSD one and only root element animal group. So this XML is all about this one and single animal group, and all the other components nested inside it. You can have any number of dogs, any number of cats, any number of rabbits, and each of them with their names, species, color, birth date, and owner element description. So this XML describes an animal group with any number of animals inside it, and for each animal it has some other elements that structure the specific information about each of the animals that compound the whole animal group here. And returning to the namespace, at the opening tag of this root element, for setting the schema location of the XSD file we're gonna use for getting the elements to this XML document instance, we must, in this case, set the XML namespace for W3C XML schema instance and set this namespace to a prefix. By default, it can be XSI, and through that prefix that has been set with the W3C XML schema instance namespace, we can get the schema location attribute in order to set at the schema location attribute the location of the XSD file we'll use at this XML file, along with the target namespace declared inside that XSD schema. So here at the schema location attribute, the value to be set is the target namespace of the XSD file. I'm not showing the XSD file for now, but we'll see later at the second topic. But for now, I just wanted to show you how an XML document instance can refer to an external XSD, in this case, an XSD with this target namespace, animal group, and with the XSD file name, animal group.xsd. And other than the schema location value definition for the XSD, in order for us to use that namespace, that target namespace, we gotta set another namespace, a custom namespace here, associate to some other prefix or not. We could use it as a default, but for now I'd like to use the prefix explicitly, as it is a good practice to always use a prefix when declaring a namespace. So this custom namespace associated to this prefix, Daniel PM 1982, is the exact target namespace that is specified at the XSD. We'll be able to show you more clearly and with a lot of other examples how this referring can be done for importing an XSD, associating that with its own target namespace and getting that namespace associating to a custom prefix in order to use the attributes as here, the animal group ID attribute, through using the prefix column the attribute group ID equals 1, and also to get and use any element created at that XSD as here, with dog, cat, rabbit, the animal ID attributes, and the most inner elements, always using that same custom namespace prefix, which I repeat is exactly the same target namespace of the XSD file we're importing. You could have many other namespaces declared, but at least this one should exist in order to refer this prefix to the target namespace of the XSD file. The other namespace could refer to any other elements inside this own file, but should be at least one namespace and prefix associated with the target namespace of the XSD imported here. So, I hope you're liking the course, and on the next 2 lectures, we'll be designing and implementing a lot of coding and examples of XML document instances. We'll be checking their correctness and confirming that they are all well formed, as well as we'll be associating to an XSD in order to validate these examples against some XSD document schemas that I previously created before and that we'll be analyzing in depth on the next topic, which is XSD. But for now, in these first 3 classes, we'll keep our focus on XML itself and how to refer these XML files or document instances to already created XSD documents in order to validate these XMLs and in order to use the elements and attributes of these XSDs that we are using. So, if you have any doubt by now, you can send me an email, or you can also look for all the codes of our course at my GitHub, which is this down here, as well as contact me through my LinkedIn. So, thanks for watching and see you next lecture.